Hello my dear friends, up to the last class we studied different type of interference principle by the splitting of the wavefront and by the splitting of the amplitude also. So in this class we are going to study one more type of splitting of the amplitude, and this experiment is called as Michelson interferometer experiment. I told that whatever fringe we are getting, we see that by means of our spectrometer. But Michelson did a set of to view such type of fringes. So first we will discuss about the structure. What type of structure he made to get the fringes, and whatever setup he had done, that we will see. And one more important thing Michelson and Morley togetherly did on the relativity chapter. That we will study in the relativity chapter. He did that to get, in ancient time, scientists were telling there is a medium. This is your earth. This is your earth atmosphere. This is your sun. Your sunlight is coming. People were telling between the earth atmosphere and sun, there also one more medium exists, and they first named it ether medium. But this was theoretical. Theoretical means they have to prove it scientifically, experimentally. That's why Morley and Michelson did an experiment on that. That's called as Michelson-Morley experiment. And thing is that they also failed in that experiment. That's not a big thing. Michelson also did a very big, very interesting experiment in case of our interference. Let's have a look on that setup first. Construction first we'll see. Then we'll proceed to the function. What Michelson did. Michelson first took a source of energy. This is also a monochromatic source of extended energy. This is monochromatic means having a single wavelength of light, having a more number of light. That's why it's called as extended source. So this is extended. We need to make the source parallel. That's why I introduced one convex lens so that my waves will be parallel. And this wave will go to the normal. Okay, I increased. After that he took one mirror. This is one mirror, semi-silver mirror. Means the front side of the mirror is no silver, nothing. Simple glass is there. The back side is silver, but not that much, so that it will give us partial reflection, partial transmission. Then what he did, he took one mirror here. This is the first mirror he took with some knobs, two knobs for adjustment. This is the mirror M1, and he took one more glass here, and the refractive index of these two glasses are same. Thickness of these two glasses are same. These glasses, backside of these glasses is having semi-silver, but this glasses is pure glass, no side is silver. And after that he took one more mirror here, like the mirror M1, one more fully reflected mirror, means completely silver, with adjustment knob. Now I will say why he said adjustment knob. He said the adjustment knob because we can adjust the position of these two mirror. These two mirror can go this way, can go this way, can go up, down, this, and also change the position. This can rotate also. That means horizontally, vertically, up, down, whatever we want, we can change the position of this mirror. And this is the setup, and here is our eyepiece. Means we guys will observe from this place. This is our glass G1, this is our glass G2. Now we'll see what is the function, how it works. This is the construction we saw. What construction? Source, extended source, then convex lens, because due to convex lens we'll get parallel line, because we are getting such type of light, means the lights were going far apart from each other. So after that we kept one glass. Back side of the glass is partially reflected, so that part of the light will reflected and part of the light will transmitted. Then back to that we keep another glass which is completely glass, no silver part is there. And this side we kept one mirror that is completely reflectable, means that is completely silver. This mirror also completely silver, and these are free to move. Free to move means we can adjust. So see what happening now. This light came, this light also coming parallel, this light also coming parallel. Now here I have to plot a normal. That's the general concept. Film is there, light is coming means we have to plot a normal. Then only we will decide whether the light will go towards the normal or away from the normal. So this is the normal, this is the rarer medium. In the glass will be obviously the denser medium. So the light will bend towards the normal. So one more normal I need to draw here. Now what will happen? The light will go little bit apart, little bit away from the normal, because light is going from denser to rarer medium. Try to follow me, students. So light went this way. Part of the light transmitted, part of the light reflected. So one more normal I will draw here. This part went to mirror M1, this part transmitted. So this will cross, because the back of this one is not silver, not semi-silver also. This is completely free. So light can go like this. Light will fall on this M2 and this light will fall on your M1. You saw, you followed me, students. I took light, parallel lights are coming, and I considered only one light for my convenience so that easily I can make you understand. This light came, this light face and normal. So this light is bending towards the normal. One more normal is there. Part of the light is getting reflected. This angle equal to this angle. Part of the light is transmitting. So the transmission line will also pass one more glass. This glass is the plain glass. No semi-silver, nothing is there. So it can pass easily. So this reflected light will also pass towards this mirror. Now what will happen? They both will come back, because these two mirrors are completely silver, fully silver mirror. So this light come back through this way, this light also come back through this way. It will come down. And one more thing I forgot to tell you, these are arranged in such a way that make 45 degree with the base, with the horizontal. This is also 45 degree. As this is 45 degree and the light is going in 45 degree angle, so it will come perpendicularly down. Okay, like the same thing, this light will come back and it will also come like this. Means we are getting our lights like that. Whatever path covered by this light, this reflected light, the same path is not covered by the transmission light. It may be going very far, it may be going very far, it may be going less, it going less. So there will be some path difference. Everywhere in the whole chapter of interference we are watching, some path difference is there. So from the path difference we are getting whether constructive or maxima, destructive or minima. Like the same thing, we will have some path difference. Before going to path difference, I will say you one more thing. Why I introduced G2. Obviously this thing will coming to mind. If light is going, coming back, then why I will introduce G2. See student, what is happening? The light came here. At this point, what is happening? This light is passing through a medium. This medium is nothing but G1. I told when two lights are passing through air medium, then it's fine. Easily we can calculate the path difference whatever be. Suppose one of the light is passing through a medium, a glass medium. After that, I have to calculate the time or path traveled by the light inside the medium, because the refractive index of this one is different. How easily I can make you understand this one? Suppose light reached here, here also light reached. Light now, one is here, one is here. These two will start moving this way. So how fast this will go? This light can't go that much fast. This will go slower than this light. That's why I introduced this. Why I introduced? One more time I am telling. This light reflected means crossed this G1 once, went, then back, then crossing one more time to G1. That means twice going and coming back to G1. Means through a medium having refractive index mu. But what's happening in this case? The light is going, suppose G2 is not there, consider G2 is not there. This light is going this way, coming back this way, then reflecting. That means this ray is not going any medium, only going through air. So there is no medium, there is no difference, there is a huge difference between these two lines, because one is passing through a medium, one is simply going to the air medium. If I will introduce a G2 glass, means the same medium, the same material of this G1 having same refractive index of G1, then this light will also pass through this G2 and will also come back through G2. That means twice they are going coming twice, here also twice. That means both the lines, both the rays pass the medium same time. So now it will be it will be good for us to calculate the interference, whether it is constructive or destructive. You understood? This is the setup done by our great Michelson. And here our eyes here, this light is coming, this light is coming. As two types of rays are coming, there will be a superposition, as I told, destructive or constructive, whatever be, that we will see in our next expression, how mathematically we can show this one. So okay, this much is about Michelson. You understood? More important is that why we introduced G2. This is to compensate the path covered by this two light, because here light is passing two times through a medium. Here light was not passing to any medium, simply in air medium. If I will introduce a glass, then only light will pass two times in a medium. So it will be equal to this line. Then you understood this part, how light is reflecting here, transmitting here, then light is coming, interfering. Okay, in the next class we will see how we are arranging the lights, how we are getting the images. That will be in the next class. Thank you.